Yes, my dear friends, this is Vipul and I welcome you to my YouTube channel. As you can see, my dear friends, here the title of this particular video is about comparative study of group 16 elements. So first of all, I'll give you the introduction about this. The introduction says this: when you talk about group 16 elements, they are going to occupy the right hand side of the periodic table. That's a point number 1 that you need to remember. Right hand side of the periodic table. Next point is, in these elements, the last electron enters into the p orbital, and therefore these elements are also called as p block elements. So that is point number 2. That is p block elements. Alright. So point number 1, they occupy the right hand side of the periodic table. Point number 2 is that they are p block elements because the last electron enters into the p orbital. Next, they are also collectively called as chalcogens. Now, what do you mean by this one? Chalcogens. They are basically existing along with the metal in the ores. What are ores? Naturally occurring compounds which are present in the Earth's crust. So, majority of these elements are non-metals. They occur along with the metals in the natural form, in the form of ores, and that's what we call it as what? Chalcogens. Next, the very first element of this group 16 is oxygen, and therefore these elements are collectively known as oxygen family. Alright, so this is the 4 points that you need to remember. Number 1, they occupy the right hand side of the periodic table. Next is, they are p block elements because the last electron enters into the p orbital. They exist along with the metals in the form of ores in the Earth's crust, and therefore they are called as chalcogens. And because the first element is oxygen, so we call also as oxygen family. Alright, so this is the introduction of group 16 elements. I hope you have understood up to this. Now, my dear friends, I'll give you the information regarding elements of group 16 in terms of name, symbol, atomic number, and valence shell electronic configuration, which we call it as VSEC. Alright, so here we go. The first column, name. Column number 2, symbol. Next, we go into atomic number. And next, we go into VSEC. Full form is valence shell electronic configuration. So we begin. As I mentioned earlier, the very first element of this group is oxygen. Alright, so we have oxygen. Next we have is sulfur. Next is we have selenium. Next thing is we have tellurium. And the last one we have is polonium. So these are the elements. We have another element after this also, but we are going to restrict over here up to polonium. You go into the symbol. Symbol of oxygen, capital O. Sulfur is capital S. Selenium is capital S, small e. Tellurium, capital T, small e. And polonium, capital P, small e. So this is the symbol of the elements. You go to the next one. Atomic number. The atomic number of oxygen is 8. How much is 8? Now I give you a very simple trick to remember the atomic number of the rest of the elements. How it is? See, as we go from oxygen to sulfur in our periodic table, we are traversing the entire rotation, entire power. And in this entire rotation, there are going to be S and the P block elements. So, in other words, we say S and the P orbital. The capacity of S is 2, capacity of P is 6, so 2 plus 6 is 8, and plus 16. So 16 is the atomic number of sulfur. As we go from sulfur to selenium, we go for another rotation. And in that rotation, we have S, P and the D orbitals. S 2 electrons, P 6 and D is 10. 2 plus 6 plus 10, 18. 18 and 16, yes, 34 my dear friends. Okay, from selenium to tellurium, once again the same rotations we have, S, P and D. So that is 2 plus 6 plus 10 is 18. 18 plus 34 comes out to be what? 52. Now why have I repeated this? Because you have learned that when we talk about D orbitals, they start from the second last shell. Okay, so one rotation for the second last shell and one rotation for the last shell. Next, as we go from tellurium to polonium, we go into S, P, D and F. So 2 plus 6, 8, 8 plus 10, 18 and 14 of F, so 32. So 32 and 52 gives you 84. So this is, my dear friends, a simple trick. If you understand the atomic number, remember the atomic number of the first element, oxygen, and if you can remember these rotations, you will easily get the atomic numbers. No need to buy heart. Alright? Okay. We go to the next part now, and that is VSEC. It's valence shell, outermost shell. When I want to write down the electronic configuration with the atomic number name, and if I write it down from say 1s, so I got 1s2, 2s2, and 3, 4. 2 plus 2 plus 4 gives you 8. But then, as I said, it's valence shell. It's the outermost shell. So therefore, the outermost shell is the second shell. So we are not going to consider 1s. Getting it? So it is 2s2 into B, 4. This becomes the VSEC of oxygen. Now one more hint I would like to give you, a shortcut, and that is my reference. In a particular group, as we go from the first element towards the last element, the number of electrons in the orbitals remains the same. But the number of shell increases by 1. Once again I repeat, the number of electrons in the orbitals remains the same. Only the number of shell goes on increasing by 1. So tell me, my dear friends, what should be the VSEC of sulfur? If I am going to increase this 2 by 1, it gives me what? 3. Oh yes. So the answer is 3s2, 3b, 4. Next we have is 4s2, 4b, 4. Next we have is 5s2, 5b, 4. And the last we have is 6s2, 6b, 4. Okay, these are the VSEC. So if you want to write down the general VSEC of group 16 elements, I just write it down as NH2 and NP4, where the minimum value of N should be 2. Because I am considering the p orbital as well. P orbital doesn't start from the first shell, it starts from the second shell. And that's why the minimum value of N is what? 2. So if I have the exact value of N, I can tell you which element am I representing. Am I right? So suppose if the value of N is 4, 4 means it is selenium. If it is 6, that means it is what? Polonium. If it is 2, that means what it is? Oxygen. Alright? So my dear friends, this is what is the tabular format of the basic information of elements of group 16 with respect to the first column that we have is the name, second is symbol, third is atomic number, and the last one is VSEC. I hope you have understood this, my dear friends. Please have a look at it. Alright, my dear friends. Once we understand the basic information of the elements of group 16, we now move on to the next part, and that is physical properties. Okay? So we begin with the very first physical property is atomic size. Okay? So we go into atomic size. My dear friends, when we talk about atomic size, very simple, it's the distance between the nucleus and the outermost shell. Okay? Now the nucleus is always going to be at the center, no doubt about it. But still, as we go on differing the elements, the atomic size differs. So it means it is very clear. Atomic size depends upon what? Yes, the valence shell, the outermost shell. Now, when I explain you the basic information, you know very well as we go from oxygen to polonium, the number of shell goes on increasing by 1. And if the number of shell goes on increasing by 1, so it's very obvious, its distance from the nucleus also increases. And that distance, my dear friends, is atomic size. Okay? So, atomic size, when we say, is the distance between the nucleus and the outermost shell. Alright? So, it means that as we go from oxygen to polonium, the outermost shell, that is this, goes on increasing. And therefore, we say the atomic size also increases in that particular order. So accordingly what we say is, oxygen is going to be smallest because it's having only 2 shells, and polonium will be the largest because it has got 6 shells amongst group 16. Now please be very clear. Okay, here the comparison is only and only amongst these 5 elements: oxygen, sulfur, selenium, tellurium and polonium. So amongst group 16, oxygen is smallest, polonium is largest. That is what its atomic size is. Alright? Wow. Next we go into, and that is ionization potential. Now before I explain you ionization potential, let me just explain you some basics of this. Okay? And the basic is, now when we consider a nucleus, it's going to be at the center. Outside the nucleus, there are going to be shells containing orbitals, orbitals containing electrons. Alright? So I show an electron which is present in the valence shell. Generally, remember that the addition and the removal of the electron takes place in the valence shell. So I show an electron over here. I consider this as an atom. And if I were to show it like this, the electron and this arrow, you understand. So that means this atom is losing an electron. The electron is going out. And remember, my dear friends, whether it's going to be a gain of electron or going to be a loss of electron, always energy is associated. And another thing we need to remember is the direction is always opposite. That means if the electron is going out, the energy goes in, and vice versa. So here the electron is going out, so the energy is going in. And this energy is called as ionization potential. Similarly, if the electron is coming in, that is the atom is accepting an electron, gaining an electron, then it is going to give away energy. Okay, so the energy is released. And this release of energy is called as electron gain enthalpy, my dear friends. Okay, I call it as EGE. Or I also call it as electron affinity, that is EA. Okay, so it's electron gain enthalpy, or what we call it as electron affinity. Okay, so now we go into ionization potential. It depends upon the size. So what did I say? That atomic size, as we go from oxygen to polonium, increases. Oxygen is smallest and polonium is largest. So when you consider polonium, the electron is far away from the nucleus. And when it is far away from the nucleus, its hold on that particular electron is less. And therefore, it can be easily removed. That means I give some amount of energy, the electron is out. It's as simple as that. So, the ionization potential is less. But when I talk about oxygen is small. So, the electron is very close to the nucleus. Nucleus is strongly holding the electron. So if I want to remove the electron from the strong hold of the nucleus, I need to give more energy. So that means in oxygen, the ionization potential is highest. Now when I talk about ionization potential, oxygen to polonium. So in oxygen it will be called highest. And in polonium it is going to be least. And therefore, as we go from the highest to the least part, or highest to the lowest part, we show this down below. Okay, so as we go from oxygen to polonium, the ionization potential goes on decreasing. The atomic size goes on increasing. And therefore, my dear friends, we come to an important relationship, and that is atomic size is inversely proportional to ionization potential, or what we call it as ionization enthalpy. That's it. Okay, I hope you have understood about this. Let's go into the next physical property, and that is about electronegativity. Now when I talk about electronegativity, to attract it. Okay, it is a tendency to attract it. Now that in turn depends upon the holder of the nucleus. Because electron is negatively charged and the nucleus is positively charged. So if the holder of the nucleus is more, the positivity is more. If the positivity is more, the attraction is half, and therefore the electronegativity is half. Alright? It's as simple as that. So oxygen has the smallest size. So nucleus has got the highest hold on the outermost electron. That is, nuclear charge is going to be high. The positivity is high, and therefore oxygen is having a capacity to attract electron very easily, a very high capacity, and therefore its electronegativity is highest. For your knowledge, my students, I tell you that in the entire periodic table it comes at number 2. The first one is fluorine. But because fluorine belongs to group number 17, and we are here discussing about group number 16, so that's why I say that amongst group 16 elements, oxygen has got the highest electronegativity. Okay, so as we go from oxygen to polonium, oxygen electronegativity is highest. As we go towards polonium, the size goes on increasing. The holder of the nucleus goes down. So positivity goes next, and if the positivity goes down, the tendency to attract the electron also becomes less. And this tendency is electronegativity. And therefore we say, in case of polonium, the electronegativity is lowest. So simple, highest to lowest if we go, so we show it by down. That means the electronegativity goes on decreasing. So if you are going to relate this with atomic size, what we can say is atomic size is inversely proportional to electronegativity. Okay? It's inversely proportional to what? Electronegativity. Okay? Now, we go into the next one. I've already explained to you what is that particular one. Electron gain enthalpy. It's also called as electron affinity. Okay? Electron gain enthalpy, or I call it as electron affinity. Now, what is the difference by it? It is a tendency of an element to accept electrons. Okay? Both of them start with A, but there is a difference by it. Attraction and acceptance. Okay? In simple words, I tell you so that you can understand this much more better, and that is some spice to this particular concept, and that is किसी को आकर्षित करना और किसी को हासिल करना, उसमें अंतर होता है दोस्तों, और वही अंतर है दोस्तों between electronegativity and electron gain. Because that's what the normal question is. What is the difference? This is the difference. And because of this slight difference, there is going to be a slight difference as far as the order is concerned. So let us go into the order of electron. So once again I repeat, it's a tendency of an element to accept electron. So we start with the first particular response. But before I begin, let me tell you one thing else. More readily the electron is accepted, higher energy is released. And this energy release is called as electron gain enthalpy. So electron gain enthalpy is high. So more easily the electron is accepted, more energy is released. So, in other words, if the electron is accepted with difficulty, energy release will be less. And therefore the electron gain enthalpy will be less. Got it? So we start with oxygen. Oxygen has got a smaller size, the nuclear charge is more, positivity is more, its tendency to attract the electron is more, and therefore its electronegativity is higher. But then here I'm talking about accepted. So when the electron is going to be accepted, conditions changes, isn't it? Okay? जैसे मैंने बोला था, किसी को आकर्षित करना है आसानी से कर सकते हो, लेकिन उसी को अगर आपको हासिल करना है तो इतनी आसान होना जरूरी नहीं है. तो ऐसा कुछ यहाँ पर है. When it comes for the electron to be accepted by oxygen, then what happens is the electrons which are already present around the oxygen, they are very close to each other because the size is less, and therefore there is electron-electron repulsion, there is negativity, and the electron which is coming in, that is called as an incoming electron, also has a negative charge. So because of that, the force of repulsion is more. Okay, so in case of oxygen, the incoming electron experiences a greater force of repulsion. Okay, by the electron which are already present in the oxygen. So The reason is very simple, because the size is less. So electrons are very close, so therefore the repulsions are very. But my dear friends, when we talk about sulfur, the atomic size comparatively is more. So if the size is more, expansion takes place. The electron distribution takes place. Okay, so it is going to be distribution of electrons. The spreading of electrons. And because of that, the electron-electron repulsion decreases. In other words, we can say when I compare with oxygen, the electron is more easily accepted. ऑक्सीजन के पास पावर है इलेक्ट्रॉन को अट्रैक्ट करने की, लेकिन जब हासिल करने की बारी आती है तो वो थोड़ा कम हो जाता है, लेकिन सल्फर जल्दी से हासिल कर लेगा. ओके, बिकॉज द इनकमिंग इलेक्ट्रॉन विल हैव अ लेसर फोर्स ऑफ रिपल्शन. सो अगर आसानी से हासिल कर लिया तो एनर्जी रिलीज इज गोइंग टू बी व्हाट. ओके, नेक्स्ट इज व्हेन वी टॉक अबाउट सेलेनियम टू टेलुरियम टू पोलोनियम, द एटॉमिc size goes on increasing. The nuclear positive charge goes on decreasing. The attraction becomes less. दोस्तों हमेशा याद रखिए, the first step is attraction and then comes acceptance. अगर attraction ही नहीं है तो acceptance का सवाल ही पैदा नहीं होता दोस्तों. तो अगर यहाँ पर attraction कम होते जाएगा तो obviously acceptance भी कम होते जाएगा, और अगर acceptance कम होते गया तो energy release will be less. And that is what we say, electron gain enthalpy is less. Energy release is less. So finally, when you need to go for the order of electron gain enthalpy, what we need to say is oxygen, sulfur. So sulfur is going to be more, and then onwards, selenium, tellurium, polonium. It is going to continuously. What is going to happen is decrease. Continuous decrease in the energy release, because the simple reason is size goes on decreasing. With that, the nuclear attraction decreases. Attraction comes, acceptance less. So this is, my dear friends, the order of electron gain enthalpy. So we can say sulfur has the highest electron gain enthalpy in group number 16. So please remember, my dear friends, oxygen electronegativity is more than sulfur, but the electron gain enthalpy of oxygen is less than sulfur. Alright? So I hope you have understood this explanation. Yes. Now, my dear friends, we go into the next part, and that is called as metallic and non-metallic character. Okay, now बहुत simple. Character means property. So property of metal, property of a non-metal. That is what we are going to discuss over here. The metallic and the non-metallic character. Alright. Now what is it? In simple words, the tendency to lose electron is a metallic character. The tendency to gain electron is a non-metallic character. Okay? Now, that tendency depends upon the atomic size. So that's why, my dear friends, in most of the cases, atomic size is a fundamental property. Once you understand that, then you can relate it to various other properties. Okay? So, first of all, let us go into the fundamental property. So when you talk about atomic size, as you go from oxygen to polonium, the atomic size goes on increasing. Okay? So that means the oxygen is going to be smallest and polonium is going to be what? Largest. Now when it is going to be smallest, the nuclear charge which is positive is going to be highest. Isn't it? Because the older the nucleus is going to be more. So the positivity is going to be high. If the positivity is high, its tendency to gain the electron is more, because the electron is negatively charged. Okay, so this is all about gain of electron. And when I talk about gain of electrons, obviously I am talking about a non-metallic character. Okay, I talk about what? Non-metallic character. And it is exactly opposite of this. Chemistry की पढ़ाई ऐसी होती है दोस्तों. You understand my concept? You relate it to the other, it becomes very easy. Okay, so polonium is being largest, so the nuclear charge that is positive is going to be less. Okay, and because of which, what happens is there is a greater tendency to lose electrons. So that's loss of electrons. Loss of electron, my dear friends, is a metallic character. Okay, it is what? A metallic character. Got it? So we start from oxygen, which is non-metallic character. We end with polonium, which has got a metallic character. So as a result of this, if I go for the two orders, metallic and non-metallic, oxygen, sulfur, selenium, tellurium, polonium, oxygen, sulfur, selenium, tellurium, polonium. Okay, you find out one order, make it exactly the reverse, you get the other order. So when you go for the metallic order, polonium, highest metallic character. Okay, so obviously you can show this. And make the opposite of this, you get the non-metallic order. The non-metallic order, so that means oxygen is highly non-metallic, so it will be this way. Alright, so this is what the order of metallic and non-metallic character with respect to group 16 elements. So therefore, on the basis of this order, we can write down some conclusions as well. What is the conclusions? Oxygen and sulfur are distinctly non-metals. When I use the word distinctly non-metals का मतलब कि वो हमेशा non-metallic character दिखाएगा, यानी वो metallic character नहीं दिखा सकता. Selenium and tellurium are metalloids. Now what does it mean is that they can show metallic as well as non-metallic character depending upon the conditions in which the reaction takes place, depending upon the nature of the species with which it reacts. Okay, that will decide its metallic or non-metallic character, and therefore we call it as metalloid. And finally, polonium. Polonium is distinctly a metal. It will not show non-metallic character. But my dear friends, one point which I want to mention, and that is, it is radioactive. Okay, radioactive means it has an ability to emit, give away radiations. Radiation is a form of energy. So polonium is giving away energy. Now, why it is giving away energy? Because it has got energy. And because it has got energy, it is unstable. So therefore, generally we say radioactive substances are comparatively unstable to that of the non-radioactive substances. Okay, so this I can call it as unstable. Alright, so this is my evidence about the grade or the order of metallic and non-metallic character with respect to elements of group 16.